In this result, our focus will be that we found statistically significant across the both sig and adjusted sig value for the group sorghum and millet based feed. Hello and welcome. In this video, I'm going to present the Kruskal Wallis tests using real-world examples. And I want to apply the test in agricultural setting. And I have this interesting topic that you might be interested in: impact of livestock feed type on daily weight gain and feed conversion efficiency in broilers. Okay, so because most times you see a lot of YouTube videos on behavioral science, attitudinal research, and so on. But in this particular video, I want to bring the Kruskal Wallis test down to real world application, and I feel that those in agricultural science, those in pure natural sciences, would be able to find this video interesting because it is more applicable to things that we see. For example, the issue of feeding broilers and then using the Kruskal Wallis test to check the differences in the feed type. So you can see that the independent variable here is the feed type, and they are in three groups. So I have the maize based, I have the sorghum based, and I have the millet based. So which means the broilers were fed with feed made of maize, another feed made of sorghum, and then another feed made of millet. And I have two dependent variables here, and the first one is daily weight gain, while the second one is feed conversion efficiency. So we want to see how the three feeding type or feed type significantly differ across the three groups and how they affect the broilers in terms of daily weight gains, in terms of feed conversion efficiency. Okay, so let us head over to the SPSS. And in the SPSS, you can see that I've got the two dependent variables. The first one is the feed conversion. The second one is the weight gain, the daily weight gain. Now, to perform the Kruskal Wallis test, I need you to have an idea about what and why we need to perform the Kruskal Wallis test. The first reason is that the dependent variable must violate the assumptions of normality. That is one. Two, it must violate the assumption of homogeneity of variance, or where you will talk about the homoscedasticity. So in this case, let us assume that these dependent variables failed these assumptions. The independent variable, like I explained before, if I turn this on, you will see that they are already coded. So I've got the maize, the sorghum, the millet based feed. Okay, and then I have I have 90 observations. So we will progress to run the Kruskal Wallis test, which is an equivalent test for the one-way ANOVA test. Why is it an equivalent test for the one-way ANOVA test? Remember that for a one-way ANOVA test, you need to have at least 3 groups and more, between 3 more groups. If it is just 2 groups, then you may have to consider t-tests or an equivalent test, which is Mann-Whitney test. Supposing you want to check whether they failed or met normality, you might want to come to this place. You go to descriptive, you go to explore, then you put the both tests into here. the dependent list, you go to plot. I'll uncheck here, check the histogram and normality plot, and then I'll click OK, and then I will click OK. So this gives us the result for the normality test. And here we are interested in the test of normality, which is the Shapiro-Wilk test and Kolmogorov-Smirnov tests. So you can see that both sig values are not statistically significant, meaning that the data did not violate the assumptions of normality. Okay, because here, if the both sig values are statistically significant, then the normality analysis is violated. So even though that this test of normality is showing evidence that the data might be normally distributed, but further analysis, further results do not seem to prove so. Okay, so but to perform the Kruskal Wallis test, we'll go to analyze and we head to non-parametric tests. Then the first one, the first step we're going to take to give us an idea whether we will proceed further to test the post hoc test is to first check the K independent samples. So we'll select the both dependent variables together and put into the test variable list, and every other thing remains as it is. Then we check, take the feed type, and then remember that we have the minimum as 1, maximum as 3, because we've got 3 groups. Okay, we've got the 3 groups: the sorghum, millet, and maize feed. So we click OK, and then it is already on check on Kruskal Wallis H test. Then we click OK. Now we will look at the results and then see the ranks, okay? Because the Kruskal Wallis test is a rank test. So you will see that under the first dependent variable, which is feed conversion efficiency, you see the 3 types of feed. So you see the maize-based, the sorghum-based, the millet-based, and you see the total number of records, okay? So we've got 28 records for maize feed. We have that for the sorghum, we have that for the millet, and here we have their rank, the mean rank. Okay, we have that of the maize as 46.48 in terms of the mean ranking, then 43.06 for sorghum, and then 47.05 for millet. Then for the weight gain, okay, which is for the second dependent variable weight gain, we have that under the maize, just like we have the numbers remain, the n, which is the number of observations, remain constant across the 2 dependent variables. But again, their ranking also changed. So we have 43.2 for maize, 35.6 for sorghum, and then 57.48 for millet based. So the analysis showed evidence of statistically significant results. So we have that the sig value here is 0.004. So showing that there is somewhere in this analysis where significant differences exist. Okay, so we need to find out, we need to probe that particular one to find out where it happened. All right, now to do that, then we use the second approach to run the analysis and then probe the pairwise comparison test. Now remember that if we had come to this point and this is not statistically significant, we will fail to reject the null hypothesis, and then we will report this result exactly the way it is, and that ends the analysis. Okay, now but because that this statistically significant result is here, then we will have to go to analyze, and then we go to non-parametric test, and then we use the independent samples, that is this one. And here we'll go to the field and select both dependent variables. and then the feed type would be groups. Okay, and then we'll go to the setting. Under the customer tests, we will select the Kruskal Wallis test, and then we will run the analysis again. So one good thing about using this secondary approach is that the secondary approach gives you the decision immediately. It gives you the clearer decision immediately. It tells you whether to reject or to accept or return the null hypothesis. So you can see that the distribution of feed conversion efficiency is the same across categories of the feed type. So you can see that for the Kruskal Wallis test, for the first dependent variable, we will return the null hypothesis. Okay, we will return the null hypothesis, showing that the distribution of feed conversion across the three categories remain the same. So normally what we could have done here would have been to remove this particular dependent variable after we had done this first step. Well, after we had taken this first step, all right, we could have removed this because it is not statistically significant. I mean, if you go down the result that we have, you will notice that under the pairwise test, the pairwise comparison test, it only checked for the weight gain. Okay, it only checked for the weight gain because the feed conversion efficiency is not statistically significant. Look at that. The feed conversion across feed type, you can see it is not statistically significant. So normally we are not supposed to have even included that in the second method that we used. It could have been dropped at this point, but I decided to allow it to be so that we can understand it, this analysis better. Okay, for the second dependent variable, which is weight gain across feed type, you can see that the test statistics, which is the Kruskal Wallis test, is 11.219, and asymptotic significant result is 0.004, just like what we have in the first method that we took. Okay, you can see that here for this part. Okay, under the pairwise comparison test, this is where I want you to pay attention, because you can see that for the sorghum based and millet based feed type, the test is statistically significant, and then when the comparison test is adjusted, that is this where you have the sig value, you have the adjusted sig value, you will see that when adjusted, the sig value still remains statistically significant, indicating that for the broilers fed using sorghum based feed, that is a reduction, because you can see that the statistical significance, the Kruskal Wallis test has a negative value on it, indicating a reduction among the broilers fed using the sorghum based feed when compared to those fed using millet based feed. Okay, now if you look at the maize based and millet based here, you will see that though you have a reduction when compared to those fed with millets, that is this, you will see that the sig value is statistically significant, but when adjusted, it is no longer statistically significant. All right, so in this result, our focus will be that we found statistically significant across the both sig and adjusted sig value for the group sorghum and millet based feed. But you can see in this case only the sig value is statistically significant, but the adjusted is not. All right, then when we look at the figure here, it also tells us the pairwise comparison using a figure. But I'm going to pause the video to write out the result for you. Write out the the interpretation in the Microsoft Word. So to do that, I'm going to copy the results into the Microsoft Word, and so I'm going to copy this. So I have my results, paste the video. Okay. Then I will copy the ranks, paste. Then I will copy the test statistics for both dependent variables. And then the last that I would like to copy is the result of the pairwise comparison. Good. So these are the results that we need for the full test of Kruskal Wallis tests analysis for your thesis or journal article. Okay, so let me pause the video and then interpret the results. So you can see that in the analysis also that the samples between sorghum based and maize based has no statistically significant results. Okay, so you can see that both the sig value and adjusted sig value all remain constant, so that means that we do not have evidence of any change in their meal types, okay, across the broilers fed using these two different feeds. So to write out your results in your thesis or your journal article, this is how you are going to write it. So you can pause this video and then copy this or screenshot this, so this can guide you on how you can write out your own result. So it reads: the result of the Kruskal Wallis H test showed a statistically significant difference across two feed types, that is sorghum based versus millet based feed. Okay, yep. The test statistics, which is this, indicates a large difference in ranked median daily weight gain between broilers fed sorghum and millet based diets, and the p-value is this and adjusted p-value is this. Of course, if you look at that, this is where I am picking this from. Okay, here. Then for the maize based versus millet based feed, the test statistics shows some difference between the two feed types. The raw p-value equal to 0.036 is less than this. So, but after adjustments for the multiple comparison, the analysis became greater than 0.05, indicating that we could no longer confirm that there's change in the feed type. So this means that any observed difference in median daily weight gain between the two feeding types or the two feed types could be due to chance. So the Kruskal Wallis post hoc result indicate that feed type significantly influences broiler daily weight gain, but the difference is specifically between sorghum and millet based feed. The millet feed group produced significantly higher median weight gain compared to the sorghum based group, while maize based and millet based feed did not differ significantly after adjusting for the multiple tests. So you can see that is on the pairwise comparison test here. Okay, and again, if you look at the rank order, it will also give you an idea of what the pairwise comparison test is telling us regarding the differences across the feed type on feed conversion efficiency. the results showed no statistically significant evidence. What this simply means is that we do not have any evidence, any statistical evidence, although the evidence might be different in the real life. I have done a video before where I explained the differences between p-value in research and p-value in the real life. Why they would definitely be possible changes in their feed conversion efficiency. The analysis here shows that we do not have any statistical evidence to back the claim. Okay, all right, and that is why the Kruskal Wallis test, told us to retain the null hypothesis, that the distribution of feed conversion efficiency is the same across the categories of feed type. All right, thank you so much for watching, and I hope you find this video helpful. Please share, like, and leave your comment down the comment section below. If you have questions, please kindly drop down your question into the comment section below, so I'll be able to look at that your questions and then respond to them. Thank you so much for watching.